Alrighty, so here's our quick tutorial. Here's a bit of an extension of what we've been doing. We've been looking at graphs a ton, and the reason we do that is so that we can find some trends and some patterns. And in physics, we call those equations. So I'm going to show you a couple of equations that we will generalize in this class. You are not expected to have to derive these on the spot, but you are expected to know how to use them. So the purpose of this video is how to use equations for word problems. Right? We haven't really done this too much. We've done mostly interpreting graphs, looking at slopes, looking at areas, and then just reading the general trends. But we can get equations from those patterns that we see and use them for a variety of different purposes. So here we go. We're going to first go through a little bit of where they come from. So that equation up at the top came from a graph. Alright, so that comes from finding the slope of a velocity time graph. So here we go. We've got the general form of, this is the general form of the slope of a velocity time graph. Okay, if I expand that out a little bit, then we can rewrite it in a way that we can see what a general trend is here. So that's the slope of that graph. So I'm going to redo, what I'm going to do is redraw it. Or, no, excuse me. Do some algebra. That's what I'm trying to say. We're going to do some algebra on it. Okay, so we've got our delta V over delta T equals A. Alright, all I did was flip it around, and then I'm going to rewrite it so that it is in terms of the equation you saw on the other page. So, alright, so we've got delta V equals A delta T. Delta T. And so I'm going to expand out that delta V into something that will help us rewrite that in terms of an equation that's useful. Okay, so we've got, oops, let me go back. Okay, so we got this. All I did here was, for delta V, I just did our final minus our initial. So our V minus V naught. That'll be the general form. Okay, so what we'll have here is, we'll have something that looks like this. And that looks very similar to what we wrote when we drew the graph. And if you look at any general formula sheet for physics, this is usually the very first equation that you'll see. But they rewrote it slightly differently. So instead of saying delta T for everything, we're just going to say T. So that's just going to be assumed the total time. Okay? So what we'll do is I'll show you one more equation like this. So some of you guys actually did this one day last week, but in case you didn't see that, I'm going to show you where it comes from. So it also comes from a graph. Excuse me. So it comes from a graph, and this one is a velocity time graph. And so what we're doing here is we are taking the area. We're taking the area and we're generalizing it into an equation. So the area, in general, is the displacement. And this is for a velocity time graph. Okay, so what we're going to do is we're going to write this as an area of a rectangle plus the area of a triangle. But we're going to do it with variables, so that way we have one equation we can use for a number of situations. Okay, so we're going to give this some variables here. Okay, so we're going to look at two different pieces. Area of this rectangle, area of the triangle. And so remember, the area of a rectangle is just length times width. And our length here is time, t. Our width is v naught. So we call this our initial velocity. So this v naught here is the height of this side, right there. T is the length of this side. So if we multiply them together, in general, we have an area. So that's our area of the rectangle. Then we want to do the area of the triangle. So 1/2 base times height. Our base is time. so the length of the bottom is time. Then our height is actually going to be this total height v minus v naught, because we only want this length here. That's the only part we want for the triangle. So I'm going to write that as v minus v0, and then it's times the time. Okay? Now if we add those together, that's, in general, the area under that curve. So area under that curve. Alright? So displacement is those two things added together. All I did was add them together. But what I want to do here, I want to rewrite this little thing in the parentheses in terms of acceleration. And that way we'll get it into a general form that's more useful. So remember that v minus v0 is the same as delta v. And we already have an equation that we figured out before that relates those two things together. So what we want to do is rewrite it in terms of delta v. So that way, what we can do here is we can plug this into here. We can plug that into there, and then we're going to get a general form of this equation that we can use. So AT is equal to delta V. So instead of writing delta V over and over, I'm just going to write T, so it's easier. So when we substitute that in, we have just exactly what we got right here. So right here is our A times T, and that's our substitution. But we can simplify that to a T squared. So what we got is 1/2 AT squared, and then that's plus velocity times time. So that's another general equation. Alright, now what do we do with these? I'm going to give you an example of a word problem. So how do we use these equations? Alright, here is an example. We are going to use a word problem that uses the first equation. Now with all these problems, all you have to do is find out what variables you know, and then circle the one you don't know, and then algebraically solve for it. So think of this as like a math puzzle. Alright, so this is our problem here. We've got a car. It's moving at an initial velocity of 10 meters per second to the right. Then it's going to start slowing down. So it's moving to the right, but then it's going to start slowing down. So it's going to get slower and slower. And I'm going to say that its final velocity is 3. So we went from 10 meters per second to 3 meters per second. And our acceleration, I'm going to say, is minus 1 meters per second per second. And then the question I want to ask, if this was a word problem, I would give you those three things, and then a question I could ask is solve this for t. So how long did it take to go from 10 meters per second to 3 meters per second? So that's what we want to find. So we've got velocity equals, so this is our equation that we are going to use now. So I'm going to solve this originally for t before I plug the numbers in. So I'm going to solve that for t, and then I'm going to plug in all my numbers right there. So here we go. So 3 meters per second was the final speed, final velocity, minus our initial was 10, divided by -1, so that's our acceleration. When you crank all that out on the calculator, you're going to get 7 seconds. So it took 7 seconds to change the speed with that acceleration. Alright, so here's a quick description of variables and what they all mean. So when you see words like this in a word problem, like final velocity, initial velocity, acceleration, time, and position, then those are the variables that we have to label so that we know where to plug them into the equation. So if it says an object, its final velocity equals this, then it's v equals that number. The initial velocity was, like in our example, was 10. then we'll label v0 as 10, and then so on and so forth. So whenever the words in the word problem say something like has an acceleration of, then we're going to label that as A. So a good way to practice doing these, which you'll have more time in class to do, a good practice is to draw a picture, so that way we get a sense of what's happening. We want to label the picture with variables. So like in my example, what we did is, let's go back to the picture here. Let's see. Here we go. I passed it. So while we were reading the problem, I labeled everything. So I labeled initial velocity as 10. I labeled final velocity as 3. Your acceleration is -1. And then we said, okay, what do we want to find? And we want to find the time. Alright, so that's what we did. And then, right, the last step here is to write down what you're looking for. So that way when you plug into equations, you know what you're solving for. And then the last step is write down any equations that are going to be relevant to your problem that you're doing. And for now, we don't have very many. We have 2 or 3 that we're going to use. So hopefully this helps. I would recommend watching this again, especially the part when we do the word problem, because that's really what we're going to practice more of. We're not going to be deriving all the equations every time we do a problem. We're going to use the formulas. Alright, guys. See you tomorrow.